Okay, question 4. The first thing we've got to do is this binomial expansion. Now, in your formula book, you are given a binomial expansion for 1 plus x to the power n. So all you need to do is decide what you need n to be in this particular case. Generate the first few terms, okay, and stop when you reach the term in x squared. So that should be a nice easy start, and you have examples in your notes if you're desperate. Then it says hence or otherwise, so that suggests there's a link between these two parts. Well, in this particular case, you may prefer to start all over again, but there's a hint anyway that this is not completely unrelated to that. What we've got here, you should be able to see why this involves a bracket to the power minus a half like we had before with a 1 here, but we don't have 1 plus x anymore. So we're doing an expansion that is similar to the one we had before, but x has been replaced by something. And you can do it in the normal way by starting from scratch, but you can use your previous answer if you want to. That's why it says hence or otherwise. Okay, and then we need to use that answer. It gives us an x value to substitute in, and it tells us we're going to get this approximation. Now remember, when you get to do a binomial expansion, you've got the original expression, okay, which will be exactly what we want, and then on the other side, because we've stopped after some number of terms, it will only be an approximation valid for small x to this expression. So you're going to take this minus 0.1 and you're going to try substituting it into this expression and simplify that, and you're also going to substitute it into your expansion with the constant x and x squared terms and combine that. Okay, and you're hoping that the exact form, it may not simplify straight away to exactly root 5, but it's going to be something related to root 5. So once you know how this relates to root 5 after you've substituted x in as minus 0.1, then that will give you an idea of how you have to take the answer to the other side and transform it to something that should rounded be something like 2.23. But be very careful that you show what this 2.23 number is before being rounded off, because that will help your show that to be more convincing. You need to show that you've arrived on your own at this number, so if you get it to a higher degree of accuracy before you round it off, then that will help make it convincing.